Welcome to qnawire.
Okay, in this problem we have a student on an elevator. The weight of the student when the elevator is not moving is 550 newtons. Then they tell us that the total mass of the person in the elevator and the elevator itself, this is the total mass, is 850 kilograms. We want to find the acceleration of the elevator when it's reading in part A 450 newtons. So this is the normal force on the scale. So we're going to say normal force equals 450 newtons. The first thing that we want to do is find the mass of the student. So we have the mass of the elevator plus the student, but we just need the mass of the student for the first two parts. So the mass of the student is just going to be the student's weight divided by g, since weight equals mg. So that's just going to be 550 newtons divided by 9.81 meters per second squared. This is going to give us 56.1 kilograms. So we want to just find the acceleration in part A. So we're going to look at the sum of our forces, or the net force, on this student. So that's going to be equal to the mass times the acceleration. So our net forces, so if we have our elevator here, we have our little person standing on a scale. The two forces acting here are the person's weight, which of course is mg, and the normal force. And this is what the scale is reading. So our sum of our forces are n minus the weight equals ma. So our acceleration then is going to be given by n minus the weight divided by m. So this is specific to the student, the mass of the student. So the normal force here is 450 newtons, and then minus their normal weight when they're not moving, 550 newtons, divided by their mass, 56.1 kilograms. This is going to give us an acceleration of negative 1.8 meters per second squared. So they're moving downward, or they're slowing down. So this is part A, and then in part B, it's the same kind of situation, but now the the scale reads a normal force of 670 newtons. So we can use the same equation here. Our acceleration is still going to equal normal force minus their weight divided by the mass of the student. So that's now 670 newtons minus 550 newtons divided by 56.1 kilograms. And now we have an acceleration of positive 2.1 meters per second squared. So here's our two different accelerations. Then in part C, they say, why is the student in trouble if the scale now reads 0 newtons? So that means our normal force equals 0 newtons. So in this situation, if we look back up at this equation, if the normal force is equal to 0, then we have a situation where the weight is equal to the mass times acceleration. That means mg equals ma, and our acceleration is now g. So that's the same as when you're just in free fall. So if you're in free fall, this means that the cable has broken. The elevator is in free fall, so they are falling, and obviously that is bad. So that's the answer for part C. And then in part D, we now want to look at the elevator as a whole and figure out what the tension is in the cable. So now we're looking at the elevator as a whole, and we want to see the forces acting on the entire elevator, not just the student. So we now have the weight of the elevator. So that's the total weight. And the tension is what is holding the elevator up, or pulling it up. So these are our two forces now. acting on the elevator. So that means the tension minus the weight, total weight, is equal to the mass times the acceleration. And we just want to solve for the tension, so we're going to add the weight to the other side. This is going to give us ma. This is the total mass here, so m total plus the weight, which is mg, so m total times g. So this means our tension is going to be basically the total mass times the acceleration of the elevator plus g. So in part A, our acceleration is negative 1.8. So that means our tension is going to be mass of the elevator, 850 kilograms, times its acceleration, negative 1.8 meters per second squared, plus 9.8 meters per second squared. And this is equal to 6,800 newtons. So in part A, the tension is 6,800 newtons. And then they want to know the tension in part C. So tension, again, is equal to the total mass times the acceleration plus g. Now let's look at the acceleration in part C. So the acceleration is equal to g. So if we have the mass, 850 kilograms, and then we have g is equal to a, this is going to be 9.8 meters per second squared. And then we have plus g, right? So 9.8 meters per second squared. So these are just going to cancel each other out. Negative 9.8 plus 9.8 is going to be 0, which means the tension is actually equal to 0. So 0 newtons in part C because it's falling. And it looks like they don't actually ask for the tension in part B, but if you wanted to find that, you could go about it using that same equation.